Hello students, welcome back to our class. Now in this module we are going to discuss about 2 marks problems which are given frequently in board examinations from the chapter circles. So coming to the first problem, if tangents PA and PB drawn from an external point P, so this is a circle, this is the center of the circle, this is a point P. So PA is one tangent and PB is another tangent drawn to the circle. So this point of contact is A and this point of contact is B, and of course center of the circle is going to be O, are inclined each other at an angle of 80 degrees. So this is 80 degrees. Then find angle POA. So what is angle POA? This angle is equal to how much? See, in order to find this angle POA, first you need to understand one thing, that if you join O and B, okay, there are two triangles drawn POA and POB. Radius is perpendicular to the tangent through the point of contact. So we can say that triangle POA and POB both are congruent by RHS congruence. Right angle equal to right angle, hypotenuse equal to hypotenuse, side is equal to side. So therefore by RHS congruence, triangle POA is congruent to triangle POB. So by CPCT, since they are congruent, we can say that this part is equal to this part. It means this total one is equal to 80, so it is 40 degrees. This is also 40 degrees. And this angle is equal to this angle. Since it is X, this is also X. Now you want this angle X. Therefore, you can take triangle POA. In triangle POA, by the angle sum property of triangle, angle P, that is 40 degrees, plus angle A, that is 90 degrees, plus X, which is equal to 180 degrees. Right? 40 plus 90 is equal to 130, plus X is equal to 180 degrees. Therefore, X is equal to 180 minus 130 is equal to 50 degrees. So therefore, angle, what is this? Angle POA is equal to 50 degrees. This is quite simple problem. Coming to the next one, here in this, I would like to draw the figure again for better understanding. Again, T is a point outside the circle. P is one tangent and TQ is another tangent. This is point P and this is point Q. And of course center of the circle is equal to O. These two are joined. Okay. And what do you want here? TP and TQ are drawn circles with center O from an external point T. Prove that angle PTQ means this angle is equal to 2 angle OPQ. OPQ means this angle. Okay. Let this angle be some X. Let this angle be some Y. What are you going to prove here? You are going to prove that RTP. You are going to prove that angle PTQ is Y. So Y is equal to 2 times angle OPQ is equal to X. In order to prove this Y is equal to 2X, again I would like to do one thing, that I will have to join these two and join these two. Okay. Again by RHS congruence, because right angle, this is right angle, this is right angle, radius is perpendicular to the tangent through the point of contact, so that triangle OPT and OQT are congruent. Triangle OPT is congruent to triangle OQT by RHS congruence. Since they are congruent, then by by CPCT, you can say that this angle is equal to this angle, and you see this total angle is equal to 180 degrees, not 180, sorry, this angle and this angle both are supplementary angles. Since these two are supplementary angles, this angle is going to be 180 minus Y, correct? Because this is Y, this angle should be 180 minus Y. Since this is X, this is also equal to X, because in this triangle, OP and OQ both are radii, so that radii are equal. Therefore, it is an isosceles triangle. Now coming to triangle OPQ, in triangle OPQ, According to angle sum property of triangle, x plus 180 minus y is equal to x plus 180 minus y is equal to 180 degrees, right? So when you transpose both of them that side, x plus x is equal to 2x is equal to 180, plus 180 would be minus 180, minus y would be plus y. So minus 180 plus 180 gets cancelled. 2x is equal to y, so y is equal to 2x, that is what you want. See, we did two problems, both the problems depending upon the same concept. So this is what is the angle formed angle formed between the tangents drawn from an external point is always supplementary to the angle formed by the line segment joining both the points of contact at the center. So that is only the concept that helpful for us in order to answer these kind of problems. Coming to the next problem, see there are two circles drawn. This is one circle and there is one more circle drawn. Both the two circles are touching externally, and this is one tangent which is the common tangent for both the two circles, and there is one more tangent. This is one more tangent, but for the two circles, of course, this is also the common tangent. See, there are two very important words that I am going to tell you about this kind of tangents. Suppose if there is a tangent which is common for both the two circles, and if both the two circles lying on the same side of the tangent, then that tangent is said to be direct common tangent. So this tangent is said to be the direct common tangent, and this tangent is common to both the two circles and both the two circles lying on either side of the tangent. So those two circles are said to be transverse. For those two circles, this tangent is said to be the transverse common tangent. So this is transverse common tangent and this is direct common tangent. Okay. Now here the problem is, prove that the common tangent to the circles at C, where is that C? This is C. Okay. And this is common tangent PQ, and this point is given T. Okay. So now you will have to prove that the common tangent at P and Q bisects the common tangent at P and Q. What do you mean by that? You need to prove that PT is equal to TQ. PT is equal to TQ. That is what is your RTP. RTP is TP is equal to TQ. So in order to prove this TP is equal to TQ, there is one very important property of tangents, that is lengths of tangents drawn from an external point of a circle are equal. So lengths of tangents drawn from an external point of a circle are equal. Now you see, I am taking one circle of center A. Okay, so this is what is the circle from center A. For this circle only, what is the external point? Can you consider T is the external point? So if T is the external point, then there are two tangents drawn to the circle with center A. Those two tangents are TP and TC. So that we know that TP is equal to TC because both of the tangents are drawn from external point T to the circle A. That's why TP is equal to TC. Let it the first equation. And similarly, I am taking the circle with center B now. For this circle with center B, again T is the tangent. T is an external point to this circle, and TQ and TC are two tangents drawn. So we can say that TQ is equal to TC. TQ is equal to TC. So these two are two informations from this figure. If you observe both the two informations, TP is equal to TC, TQ is also equal to TC. So both are equal to TC. Can we say that TP is equal to TQ? Therefore, TP is equal to TQ. This is what we want, right? TP is equal to TQ. Therefore, T bisects the line segment PQ. That is what you need to prove. You understand? Right. So coming to the next problem here, in the given figure, OP is equal to the diameter of a circle with center O, and PA and PB are tangents. Prove that APB is an equilateral triangle. This is one of the interesting problems. So this is point O, and there is a point P given. PT is one tangent, and then PT na PA na. So PA is one tangent, as well as PB is another tangent. These two are two tangents. This is the point of contact. Of course, this is the point of contact. These two are joined. Clear? And PO is also joined, because why am I joining PO here? Where OP is equal to the diameter. So OP is equal to the diameter is nothing but here OP is equal to 2 times radius. That is what is the diameter. And of course OA is equal to radius. OB is also equal to radius. OA is equal to OB is equal to radius. So it was given in the problem. Right. Now you will have to prove that APB is an equilateral triangle. I am going to join A and B also, because you need to prove that APB, this triangle, is equilateral triangle. But before I start proving that it is equilateral triangle, first of all, I know that the triangle OPA and OBP or OPB are congruent, since triangle OAP, let us go like that. OAP is congruent to triangle OBP by, what is that congruence? RHS congruence. Since they are congruent, by CPCT, this angle is equal to this angle. Okay? So, by CPCT, we can say that PA is equal to PB, PA is equal to PB, PA is equal to PB, right? Means this side is equal to this side of this triangle I am talking about. And angle APO and angle APO is equal to angle BPO is equal to angle BPO is equal to some theta. Let it be theta. Now these two angles, these two sides are equal, then obviously triangle APB is an isosceles triangle, because two sides are already equal. If two sides are equal, then two angles are equal, then this angle is equal to this angle. Correct? So anyway, you have taken this is theta, right? That is theta. Now I am going to consider, see here it is theta and here it is 90 degrees. You know very well about this. I know about the side OP also, so that I am going to apply in triangle OAP. In triangle OAP, I apply sin theta. So sin theta is equal to side opposite to theta, that is OA, divided by hypotenuse. Hypotenuse is equal to OP. What is OA? OA is equal to radius and OP is equal to 2 times radius. So radius by 2 times radius means sin theta is equal to 1 by 2. Sin theta is equal to 1 by 2 means sin how much is equal to 1 by 2? Sin 30 degrees is equal to 1 by 2. Right? So sin 30 degrees is equal to 1 by 2. Therefore the value of theta is equal to how much? Theta is equal to 30. It means this angle is equal to 30. Then this angle is also is equal to 30, right? So 30 plus 30 is equal to 60. Means this entire angle is equal to 60 degrees. And these two angles are same. Let it be x and this is x. Okay. So in triangle APB, one angle is 60 and other two angles are equal, both are equal to x and x, that is 2x, which is equal to 180. So 60 plus how much is equal to 180? 60 plus 120 is equal to 180. So 2x is equal to 120, therefore the value of x is equal to 60 degrees. It means all the three angles, this is 60 degrees, this is also 60 degrees. All the three angles are equal in one triangle. Then what do you call the triangle? It is an equilateral triangle. So therefore, triangle APB is equilateral. So this way we can answer the problem. This is one of the most important problems. So please do remember how to solve this problem and how to prove that this triangle APB is equilateral with the help of the information given. Right? Moving on to the next problem, prove that the tangents drawn at the endpoints of the diameter of a circle are parallel. For example, this is a circle and I am taking the diameter. This is the diameter since this is the center. And there are two tangents drawn at the diameter of the circle, at the endpoints of the diameter. So this is one endpoint of the diameter, let it be A. This is another endpoint of the diameter. This is B, and this is one tangent drawn at endpoint A, and this is tangent drawn at endpoint B. Now you will have to prove that this tangent and this tangent both are parallel. So when two lines are said to be parallel, if the interior alternate angles, otherwise corresponding angles are equal, cut by a transversal, right? So now you will have to prove that AB is a transversal and AB is making these two lines, for example this is L and this is M, parallel. For that, you know radius is perpendicular to the tangent through the point of contact. So what is the angle here? This angle is equal to 90 degrees. And what is this angle here? This angle is also equal to 90 degrees because radius is perpendicular to the tangent through the point of contact. So this angle is equal to 90 degrees, this angle is equal to 90 degrees. Can we call these two lines are parallel by the transversal AB? Absolutely. So therefore, L is parallel to M. So when you answer this problem, since radius is perpendicular to the tangent through the point of contact, therefore OA is perpendicular to L at A, OB is also perpendicular to L at B. Therefore, this angle is 90, this angle is 90. These two angles are said to be interior alternate angles. They are equal. Since they are equal, L is parallel to M. You understand? So these are few set of problems given for 3 marks, which are very very important problems. So please be focused and how to answer these problems, the step by step procedure in order to solve the problems. Hope you understand. Enjoy the class. Thank you.